Welcome. Welcome to another episode of the Impact of AI and Big Data. Our sponsor this week is WILDA, Women Leaders in Data and Artificial Intelligence. Going to go straight into our introduction of Kamal Distell. She is the VP of Data and Analytics, Platforms, and Data Science at Toyota Motor Corporation. Welcome.
Well, thank you, Melissa. I'm delighted to be here and delighted to be talking about data and data science. So let's get into it.
First things first, I do follow you on LinkedIn. I did check out your page, and you are one of those individuals that you spend a lot of your time in data and analytics, but you have moved around from company to company. And I want to ask you if you found that to be an asset or a disadvantage.
Great question. So as I was building my roadmap for the future, there are some core areas that are really part of who I am. So firstly, leading. I love leading teams and really making sure that people can grow and be who they are. But the other parts of the sort of diagram are really around data science, which I've spent a lot of time in, data, which I've spent a lot of time in, IT and infrastructure, which are not the same as data, and then cybersecurity. So those are my core domains that I've really focused on. And as I was moving through my roadmap, in terms of my career, I really wanted to experience what all those domains were in different industries. And my intent was really to learn and then determine what's different, right? And also what's common and what are some of the ways that I can really think about data very differently. So it's great to have experience in a particular organization and be really domain centric and learn about that organization. But for me, my roadmap was a little bit different. I wanted to work in different industries and really experience those domains in all kinds of other areas that I haven't even thought of, right? Whether it's healthcare, whether it's automotive, whether it's transportation, et cetera.
You mentioned observing what's different and what's not. Did you answer that question?
I'm always on the journey to answer that question, right? But I did have some really good takeaways in terms of what problems you can solve in different industries, right? And some problems are very similar, whether you're looking at supply chain, right? And healthcare has supply chain and automotive has supply chain, right? But the characteristics and the context of the data and the information that you need is different, right? In one case, you're actually putting parts in a human body. And so the checks and balances are very different. And the models that you may build from a data science perspective may look very different, right? Whereas if you're building cars, the context of the data and information are different, so you may ask different questions. So I love that even though those different industries, right, all do data science and they do data, but the context of the data and information and how you think about really thinking through those future state predictions is different. And that's what makes the space so exciting, right? Because it's not just static. It's like you actually have to train your brain to think about, okay, what else am I not thinking about, right? And how would I go about adding an additional dimension to whatever it is that I'm doing?
Do you think it's possible that we can solve anything with data?
Being the data person, I really truly believe that you can, right? And why I believe it is because if you look at different industries and if you look at their maturity, right, with data, we have a long ways to go. Whereas some organizations are certainly all the way there, right? They're leveraging data. Think about ChatGPT, right? It's the new thing that everybody's talking about, and it's already learned the internet. So those are all data points, right? And some people are leveraging it in different ways and contexts. So to me, I think every problem starts with data, right? And it could be structured data, unstructured data, and how you think about it, and all different types of data. But I think you can solve any problem and get closer to the solution with data, and that is the powerful part.
So if I take that one step further, I've got a business challenge within my company. I've got a hypothesis, but I'm going to effectively use the data to refute or to support that hypothesis. Is that what you're proposing?
I think that's definitely a starting point, because everything starts with a problem, right? What problem are you trying to solve? And then what data allows you to solve those problems or challenges, or ask the additional questions, right? And yeah, you create several different hypotheses. And now with the volumes of data that we have, right, you can get to those things pretty fast, right? You don't have to wait days, months, years to be able to come up with what the sort of hypothesis is, and whether I'm refuting it or whether I'm accepting it. And then you have to have multiple hypotheses depending on what it is that you're trying to solve. So absolutely.
You mentioned volumes of data, and I kind of had to smile there because back in 1997, I was working with data, the data management group at Kearney. And back then, terabytes of data was a large set of data. And, now fast forward to, we're in 2023, and the codification of data, we talk about exobytes and zettabytes, but now I understand, and looking at the table before this call, there's now yo-yo bytes, and just recently they've added bronobytes onto the volume, because volume keeps increasing and we have to keep calling it something. So I want to keep that in mind with this next question. If I have so much data, should I be applying that 80-20 rule? Should I be only looking at 80% of the data to maximize the answer that I'm trying to get? Or is this just, I'm spinning my wheels because the data just keeps getting larger and larger?
Right. It's a great complex question to answer. So here's how I'll take a stab at it. Number one, the fact that you have so much data pooling in, right? That is power. With automation that exists, as well as how much you can glean out of the data, you have to be able to truly leverage that full power of the full data set, right? And that's ever changing and increasing every single day. But that's where machine learning comes in, right? That's where you can write amazing models and comb through all of that data to be able to look for those data points, right? The second piece I'll answer is, what problem are you trying to solve, right? And what level of precision are you okay with? Not all problems require so much precision. Like if I'm making healthcare decisions about somebody, I really want that precision, right? Because now I'm going to be impacting somebody's life. Whereas if I'm looking at some small scale use cases in terms of yes, no, if I want to move something with something smaller, I may not need that precision. I may not need all of that data to inform my decision. So the key question really is, number one, what problem am I trying to solve, right? And how much data do I truly need, right, in order to make sure that I solve the problem? And I know some people will think this is controversial because more data is always better, but that's not always the case, right? Because yes, that comes at a cost as well, right? If I'm churning through sort of extremely large volumes of data and my problem set is very small, why am I going through all of that exercise, right? So really think about, what am I trying to solve? What is my hypothesis, right? What is my prediction at the end that I'm even thinking about? And yeah, you could limit yourself, but at the same time, right, you have to kind of take a forked path and say, is this good enough for the impact that it's going to have? But if I'm really thinking about high impact areas like healthcare and sort of automotive, even where we're creating vehicles, I think it's important to make sure that you're leveraging all of the data that you have to solve the particular challenge in hand.
Kamal, you that's great. I love it. Well, he just answered the question. Yeah.
My dog answered the question.
That's great. I love it. I didn't even get to ask it. He already answered it.
Hey, stop barking. Oh, hold on. I think she will stop. Or I'm just going to be back. I'm just going to pull the shades down.
Okay.
I see. Wait, stop 1 second. How was the question framed again? So I think your question is great, right? In terms of, is more data better? Do I really think about the 80-20 rule? And here's how I'll answer it. I think it depends on what you're looking to solve and the impact of the challenge or the problem, right? That the impact that it's going to have. So an example I'll use is in healthcare, right? Where you are truly impacting people's lives. I think it's important for you to make sure that through sort of the flooding of the data that you have, that you are really thinking about precision, right? And that increased precision. Because again, somebody's life is on the line at the end, right? Whereas I think depending on the context and other problems and challenges that you have, right, the Pareto principle may be enough that you don't need that level of precision, right? So I think I, I think as a person really thinking about the challenges ahead, you've got to think about, how much data is enough, right? And I think there are different folks that would disagree with this, right? Which is, hey, we have, more data is better. We have data coming in. We have, to your point, so much data. We're in data swamps and we're data flooded, right? But at the same time, are you really able to utilize all of that data to create that precision that you're looking for? And in some cases, absolutely yes, right? But in some cases, do you need to? So I often think about, hey, what's my minimum viable data, right? And that's even controversial, right? Because some people will say, well, my minimum viable data is all of the data. But at the end of the day, what are you trying to solve for, right? Without introducing more bias into the picture, and really be thinking about, okay, is that good enough, right? Can I get to an answer soon enough? The other is also technology, right? What's your compute power? Can you even churn through all of that data and information, at an optimal cost? So depending on, the type of organization you work for. So unfortunately, we have those constraints, right? All of us. And you've got to think through those constraints and be able to kind of come up with the best possible answer and method, and then keep improving, whatever the algorithm may be.
You made a scenario about the level of precision of data in something like healthcare versus something a little bit different if I'm in professional services. And the application of this minimal viable data framework. But I guess, I'm sitting here listening to this. How would I know what the minimal viable data framework is? And how do I take these volumes of data and be able to narrow that down into what I need to answer the question?
Right. Again, a really great question, right? I think first and foremost, you have to ask the question, okay, what is the data that I even have available, right? Is there more data that I can get, right, that will allow me to add more context and additional variables to solving my particular problem? How easy is that for me to get? How expensive is that for me to get, right? So again, going back, I think we can find all kinds of data out there, right? But unfortunately, we have constraints. Some organizations have constraints, right, that they have to really think about. So my point is start with, what you have, and then make sure that you kind of keep improving and building upon that, right, with additional data, with additional variables. But don't stifle yourself so much that you can't even get to version 1, right, of the particular model. So you have to start somewhere and kind of keep building and refining. And that's the art and science of data and data science.
I have a lot of questions in my head. So, yeah. All right. Let's try to prioritize them at the moment. When I listened to what you've explained, I had a couple different thoughts. One is, okay, well, I need to understand what my risk threshold is. Applying that risk threshold concept on top of the data, I think would help provide a little bit more clarity into how much data do I really need in order to, to address the question. But now, as I'm thinking further, I completely understand what you meant earlier about minimal viable data may be considered controversial, because I didn't quite get it then, but now that you've explained it, I can understand why. Because going back to your comment, I want as much data as I can to ensure I'm making the right decision at the right time, at a point in time when it's going to impact me the most.
Right.
But what you're talking about is being able to break it up into smaller components. Is that what I'm hearing?
Right. Break it up into smaller components, break it up into manageable components, breaking up into affordable components,
Mhm.
breaking it up into available components, right? And so what you don't want to do is put so many constraints on that you're not able to get version one out, right?
Okay.
Because everything can be enhanced, improved. And yes, you are going to create some bias. You're probably going to create some ideas in terms of, hey, is this good enough? Do I take this to market? Do I not? But at the same time, again, depending on the types of organizations that you're working with, how much data you have available and accessible, and the cost, right? We all have to make those trade-offs. So part of it is just really thinking through that process and thinking through, hey, what is the hypothesis and what is the impact that this is going to have? And then really working through that journey, right? If you don't
Mhm.
feel comfortable and your risk tolerance, to your point, is not there, then wait, right? Put in more variables, pull in more data to make sure that you're getting the precision that you're looking for.
You've mentioned a couple of variables in making these decisions. One was cost, one was availability or accessibility of the data. One was, and I wouldn't have thought this, but the technology itself. Do you have the infrastructure to even process the data? We did talk about risk. Are there any more that you've used in your own framework that we haven't touched on yet?
I think the other one I would say is context, right? And
Mhm.
that's may not be as much of a measurable one. It's like, what is the context with which I'm utilizing this data and information, right? And what do I think I want to achieve? And what are the results actually telling me? So that context is very, very, very important. We just had a data science summit here, and one of the speakers actually really talked about looking at data in the context with which you're actually utilizing it, right? Because we
Mhm.
don't often think about those things. That is critical, right? In whatever industry you're working, each industry has its context, and that's where I'll kind of bring it back. As I've learned and worked in many different industries, it's developing that context with which, hey, I think there are other things that we could add to this problem statement, right? Other data that we can add to help refine it, to make it better, to be able to say, oh, let's think about this problem differently. That's the part that you get from working in different industries, or at least that's been my aspiration to work towards.
Mhm. You made a reference earlier about measuring and not really metrics, but measuring. How can we take that and apply that to the minimal viable data framework?
Yeah, measurement is critical, right?
Mhm.
And what I've also learned is a KPI is not a measurement, right? A
Okay.
KPI is something that, yes, we are all used to, we all have to follow. But measuring comes in many different ways. Measuring value, measuring satisfaction, measuring, sort of how things are going. So the best way I can answer your question in terms of
Mhm.
the role of measurement and minimum viable data is measure early and measure often, right? So as it is that, you're putting things out, whether it's a model that you're developing or an algorithm, right? Really be thinking about, hey, what is this truly telling me, right? In many different levels. And then as you're introducing more information, data, context, right, to your problem statement, measure early and measure often, and really broadcast that out and have your community weigh in to say, is this really, what am I not thinking about? Is this really giving me
Mhm.
what I think the problem statement is? And how do I introduce, sort of even more precision into this problem statement? So I think that's the best way I can answer your question.
When I think about measuring, your response a moment ago was KPIs are really not the be all end all, which I think some people might say, "Oh no, I can't believe she said that." But what I also heard in this conversation was it's not just about, yes, measure early, measure often, measure value, but you said pull the audience in, pull parts of the organization or representatives of the organization to really help with that measurement value. Did I
Right.
understand that correctly?
Yeah,
Mhm.
absolutely. Right. So I often think like, okay, what do KPIs actually tell us, right? And sometimes they just tell you whatever the outcome may be, but they don't tell you anything about the journey, right? Or the
Mhm.
root causes or along the way, right? We also measure way too many things, right? If you've ever seen some of the KPIs in the dashboards, by golly, right?
Mhm.
And so sometimes you miss sort of all of the critical things that are happening along the way because you just see this like final metric, right? And those things you don't focus on what truly may matter, right, along the way. So
Mm.
that's why I say measure early, measure often, is because they show you little mile markers along the way so that you can catch and say, okay, I may still get to the same outcome, but I may have learned a lot of other things along the way that I probably wouldn't have if I was just looking at a final KPI. And then measure things also that are correlated, right? So if you just look at the final KPI, you may have missed those correlations along the way, right, in terms of
Mm.
all the different data points that you're looking at. So I think my point is measure early, measure often, and really look at those intricate things that are happening and as the data is transforming your problem statement, right? Then you can still have your KPI at the end, but that's very outcome, doesn't show you the journey.
Yeah, I think I've just this light bulb went off that, KPIs are very transactional. And and just as with everything else, we've gotten so used to the standard KPIs and metrics that I think what I'm learning from you today is you really just need to push everything you thought you knew out the door and really just start thinking differently. And I guess that kind of, I think, ooh, light bulb. Thank you, Kamal. But I guess that's kind of where this whole concept of the minimal viable data is. And it sounds like such an easy concept at first, but I think as we've continued to unpack it here, it really encompasses a lot of new varieties of thinking. You know, not that all the data is the best, although there's other people out there who say that we have to think about the diversity of the data and the coverage of the data, but you've also illustrated in your responses that you're still pulling in the diversity because you're not relying on the KPIs as the only way of measuring the value. You're relying on the representation of the audience and the public to provide that feedback.
Right, absolutely. And also you're measuring along the way, right?
Mhm.
And you're really thinking about, okay, what data set did I put into this algorithm and did it actually yield, some of the sort of things that I was looking for? And then, okay, what else can I add to this to sort of refine the problem statement as well as get the hypothesis? So it is a complex challenge, right? And I think a lot of people may disagree, right? Like
Mhm.
more data is better. And in certain cases, absolutely, right? Like you have it, I think it's fantastic, right? But at the same time, you still kind of have to think through the journey with which what you're putting in, right? And be thoughtful about, okay, what is the problem that I'm trying to solve? And what are those factors and criteria that I really need to be thinking about? Because diversity of data and that respect for data, right, means that you truly understand as a result of this is going to be the impact, right? And that's really the art and science of data and data science.
Hmm.
Yeah.
So, Kamal, throughout today, we've talked about this concept of minimal viable data. And the word minimal tends to think that you're using the smallest data set possible. But in reality, what I think I'm hearing today is it's not a matter of what's the smallest amount of data I can use to answer the question. You're using that concept, minimal viable data, to represent what's the right amount of data.
I think you hit the nail on the head, right? So imagine that folks will say more data is better, and in
Mm-hmm.
certain contexts, absolutely more data is better. But at the same time, if your data is biased, right, just getting more data is not really going to help.
Mm-hmm.
So you really have to think about, hey, what is my data? How am I segmenting it? What is the quality of my data and information, right? And be thoughtful about your data to be able to make sure that your hypotheses, truly make sense, right? And the data that you're going to be getting. So there are two dichotomous ways to think about it. In certain contexts, absolutely more data is better. But again, if it's full of bias, right, it's not really going to help you. So you have to be really thoughtful about what is the minimum viable, correct data that I'm looking for to make sure that, my problem statement is really yielding what I'm looking for.
As we wrap up today, and folks are kind of stepping away with, from listening to this and thinking, okay, now how can I apply some of these concepts back at my office, or I'm in the similar position at you at my company. Gosh, where would I even start to even begin to think about this concept with the data that I'm currently overseeing? What are some recommendations that you can provide to those folks?
Yeah. Data is an amazing information asset, right? So one of the things that I've certainly put as part of my recipe is to really look at the inventory that we have. And there's data, we're surrounded by it in large organizations or even small organizations. So get out there and really start to think about, what types of data does my organization even hold? Where is it? Is it in a central place? Is it diversified, et cetera? And then from there, I think the next place is just, this is going to be cliche a little bit, right? But it is the quality of the information that you have, right? And we just talked about, yes, I could have tons and tons of data, but if the quality of the information that I'm getting it doesn't make sense, my results are going to be biased automatically. So spend the time in terms of really thinking through the quality of the information. The third is really the problem statement, right? What am I trying to solve for, right? And what do I need? What data do I need? What data do I have, right? And what data could I get in order to make sure that I'm really coming up with a good hypothesis and a comprehensive sort of analysis of the information itself, right? And then there are many, many other steps, right, that we can kind of take, along the way. But those are the ones where you really have to be thoughtful and mindful and respectful of the data and the information that you have to solve sort of problems of the future.
Well, I think this was a really good conversation, recognizing that probably Bronobytes is not going to be the last rung on that table that's on the internet. And as data continues to grow and grow and grow, I think we're going to have to come back to this conversation and really think about, I just need the right amount of data to solve my problem. And I think this is going to come back over time. People are going to come back with, well, minimal viable data is actually going to make a lot more sense.
Right. And I'm sure there are folks that will disagree with this, right? Which I think makes for an exciting
Mhm,
conversation, right?
mhm.
But again, we all have those challenges and constraints, right? And really be thinking about, what kind of bias am I creating, right? Even as I'm churning through unbelievable amounts of data.
Mhm.
So being thoughtful about that data is critical, right? Because you can skew your results any which way.
Well, Kamal, thank you so much for your time today.
Melissa, it was such a pleasure, and I can't wait to do this again. And thank you for talking data.